Let's see second method for centripetal acceleration. Our object is moving with constant speed of v. This is the initial position. Initial position at time t. This is the final position at time t plus dt. From this position to this position, this object has moved d theta, an angular displacement of d theta in what time? Dt. This time is t, this time is t plus dt. Object moves from this position to this position in time dt. Now, this v, it can be written in vector form like this. V initial is v j cap. This is I cap, this is what? J cap. This v, which is v final, if you want to write this v in terms of I cap and j cap, then you must resolve it first. This will be the horizontal component and this will be the vertical component. Horizontal component, vertical component for this final position. Now, if this angle is d theta, this angle is also d theta, alternate angle. Velocity is always tangential, that means it makes an angle of 90 degrees with radius. And therefore, if this is d theta, this is 90 minus d theta, this is d theta. Not a difficult task. You can yourself find this thing. If this is d theta, then this v has two components. One along the j cap direction, other one along minus I cap direction. This component is v cos d theta and this component is v sin d theta. जिसके साथ एंगल होता है that component is what? Cos. The other component is what? Sin. Now if this is final point, then velocity at this final point can be written in this form: v sin d theta, v sin d theta minus of I cap, this direction, minus of I cap, plus v cos d theta j cap. Now, in the first method for centripetal acceleration, we had written that sin theta, it can be approximated with theta if theta is very, very small. If theta is very small, then sin theta can be approximated with theta. Just like sin 0, you can remove sin, it becomes what? 0. Similarly, cos theta, it can be approximated with 1. Curve if theta is very, very small. For example, cos 0. What is cos 0? It is 1. This d theta, it means something which is very, very small, and therefore this v final, it can be written in this form. V sine d theta. If angle is very small, then you remove sine part. This is only d theta minus of I cap plus. If angle is very small, then cos of a very small angle is what? 1. And therefore, this is V j cap. Now, in the first method, we have already discussed this thing, that force, total force. What is total force? Total force has two things, centripetal component and tangential component. Tangential component, it changes what? Magnitude. हमारा ऑब्जेक्ट कांस्टेंट स्पीड से मूव कर रहा है, कांस्टेंट स्पीड से मूव कर रहा है, and therefore ft, this thing is what? 0, since v is constant. टेंजेंशियल फोर्स का काम होता है मैग्नीट्यूड चेंज करना, मैग्नीट्यूड सेम है, हम उस पर इंटरेस्टेड नहीं है, हम किस चीज में इंटरेस्टेड हैं? सेंट्रीपिटल एक्सेलरेशन। सेंट्रीपिटल एक्सेलरेशन का क्या काम होता है? डायरेक्शन चेंज करना, डायरेक्शन चेंज करना। एंड देयरफॉर F total, now what is F total? Mass into acceleration. A is Fc. What is Fc? M into AC. Ft is what? 0. F total is M into A, which is what? M into AC. Now, what is A? Everybody knows what A is. A is dV by dt. A is dV by dt. This is M AC. And therefore, M cancelled. Your centripetal acceleration is simply dV upon dt. सारी की सारी चीज अपनी सेंट्रीपिटल फोर्स एंड एक्सेलरेशन इसके फर्स्ट मेथड में की हुई है। व्हाट डू यू मीन बाय dv? dv का मतलब होता है v final minus v initial, v final minus v initial divided by dt. dv change, v final minus v initial, change which took place in what time interval? dt. Now look here, this is your v final, this is your v initial. When you subtract v final minus v initial, when you subtract v initial from v final, you can see that vj cap and vj cap, they are cancelled, and you are left with what? This part. And therefore this v final minus v initial is simply minus of v d theta I cap divided by this dt, minus of v d theta I cap divided by dt. Now look at this. What is this? Minus of v. What is d theta upon dt? This is called angular velocity, I cap. And then we also know that relation between tangential velocity v and angular velocity omega is what? V equals to R omega. Tangential velocity is V, but its angular velocity is what? Omega. And relation between these two is what? V equals to R omega. This omega, therefore, can be written as V upon R. Let's group this minus sign with I cap. क्यों? थोड़ी देर में क्लियर हो जाएगी चीज. What is centripetal acceleration coming? V square upon R minus I cap. Like AC is coming V square upon R. What is the direction? Minus I cap. If you look at the second method, you can see that the second method has given us magnitude of centripetal acceleration as well as its direction. Why? Because we are dealing with vector terms all the time. In method 1, we went for magnitude. This method, in this second method, we are using what? Complete vector form. हमने magnitude version develop नहीं किया. उसने क्या दिया आपको? What is the magnitude? V square R. V square upon R. You have seen this thing. And what is the direction? Minus I cap. What's the meaning of minus I cap? कहाँ पर आपने ये centripetal acceleration निकाला हुआ है? यहाँ पर. What is time at this place? यहाँ का time कितना है? T. When you look at this figure, तो लोगों को लगता है कि भाई यहां से यहां तक such a large portion. No, look at this angle d theta. This d theta means something like this. If somebody is looking at this circular motion at time t, look at this blue line. This blue line at this point, you are saying that time is what? T. Then, if you can feel, if you can see, if you can imagine, lower edge of this blue line represents time t, lower edge, and the upper edge represents what? Time t plus dt. dt is what? Something which is very, 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 very small. आपको समझाने के लिए यहां से यहां तक चीजों को मूव करना पड़ा है. Otherwise, ये जो आपको ब्लू लाइन दिख रही है, इसकी थिकनेस में बॉटम यू कैन से इज टाइम t and the top of the blue line is t plus dt. That means at this place, which place? At this place, which is at time t, if I ask you what is the direction of centripetal force or acceleration, तो आप क्या बोलेंगे? Minus of I cap. What is minus I cap at this position? This. ये डायरेक्शन कहां पॉइंट कर रही है? Towards the center, and therefore this is centripetal acceleration. Hopefully समझ में आ गया होगा इस सेकेंड मेथड में कितना इजीली आप centripetal acceleration डेवलप कर सकते हो. चाहिए क्या था? थोड़ा सा मैथमेटिकल पार्ट इस तरह का, अगर थीटा तुम्हारा बहुत छोटा है, then sin theta becomes theta, cos theta becomes 1, and this calculation, this mathematical part you can use everywhere in physics. जहां जहां आपको theta छोटा मिलेगा, small मिलेगा, you can use that kind of approximation. Note down everything. Let's discuss uniform circular motion. Uniform circular motion. In uniform circular motion, we know that speed of the object, it does not change. It always moves with constant speed. Now, how can we visualize this uniform circular motion? Let's take some examples. We have been given a rope of length L, and at the end of this rope, we have an object of mass m. And this mass m is moving in this circle with constant speed v. And the whole thing is happening in a horizontal plane. Rope, it's connected to this center point, and at the other end of the rope we have an object of mass m which is moving in this circle with constant speed v. Speed should be constant, then only you can say that motion is what? Uniform. And the whole setup is in horizontal plane. You can imagine that we have a frictionless table, a horizontal frictionless table, and on that frictionless table somebody is rotating this mass m like this. Suppose we have a horizontal table right here. This is the rope, and somebody is trying to rotate this mass m with the help of a rope of length L. Now, if it is a rope, then from laws of motion we know that we define this type of rope as massless rope. This rope is what? A massless rope. Whatever mass is present right here. Now, if this is massless rope, then the first thing is, what is that which makes this circular motion possible? Now, we know that in uniform circular motion there is only one force, which is what? Centripetal force. किधर लगता है centripetal force? Towards the center. Therefore, if this object is moving in a circle, then it must have a force which is acting towards the center. What is this force called? We know that centripetal force. How much is the magnitude of centripetal force? We also know that mv square upon r. R in this case you can see is what? Length of the rope. Now this Fc which is coming mv square upon L is the requirement. Listen carefully. If this object needs to move in this circle of radius L with a constant speed of v, then it is possible only if you have a centripetal force acting in this direction, and that centripetal force must have this much magnitude. But there must be something which can provide this centripetal force. ये तो रिक्वायरमेंट है, इतना चाहिए. अगर आप ऐसा सर्कल बनाना चाहते हैं, दिस इज द रिक्वायरमेंट. लेकिन कोई चीज ऐसी होनी चाहिए which can provide the centripetal force. Now you know that if we have a rope, then in a rope we know that away from the body क्या एक्ट करता है? टेंशन फोर्स T. This T is what? Tension force. What is that which provides Fc? T, and therefore this Fc is nothing but tension force T. They can ask you, find out tension force in the rope, and then what will you do? You will go for centripetal force. What is centripetal force? mv square upon r. That is the requirement. There must be something which can fulfill this requirement. For example, suppose you say that when you say that Earth is revolving around Sun, then in a circle, then it needs centripetal force. it needs centripetal force of what? mv square upon r. But there is no rope connected between sun and earth. Then what is the mechanism? What is the force which provides this necessary centripetal force? We know that gravitational pull of sun on earth gm1 m2 upon r square. ये force सुना होगा आपने शायद. This gravitational force of gm1 m2 upon r square is something that provides mv square upon r. This part is the requirement. Remember, there must be something which can fulfill this requirement. In fact, write down the statement. mv square upon r is the requirement of centripetal force. There must be some force which can provide necessary centripetal force. In the given figure, requirement of centripetal force is fulfilled by tension force in the rope. Requirement of centripetal force is fulfilled by tension force in the rope. Now you already know that tension always acts away from the body. Now, if it acts away from the body, this is the body. This is away from the body. Kidhar? Towards the center. Similarly, when Earth revolves around Sun, assuming in a circular path, in gravitation you will see that the path is elliptical, but as of now, let's focus on circular trajectory. When Earth revolves around Sun in a circular path, requirement of centripetal force is fulfilled by the gravitational pull of Sun on Earth. The same way you can say that electron, when it revolves around the nucleus in a circular path, then what is that which provides this necessary centripetal force? Electrostatic attraction of positive nucleus on the negative electron. तो अपने दिमाग में क्या रखना है? mv square upon r is the requirement. There must be something which can fulfill this requirement. इस situation में कौन है वो? Tension force T. This was the first example of uniform circular motion. इस situation में क्या था पता है आपको? The whole thing is lying on a horizontal surface. There is no friction and the object is continuously moving with constant speed v. Note down this example. Let's take another example. This time we have got two ropes and they are connected to these two objects. Let's say this is of 2 kg, this is 3 kg. They're just point masses. इस तरह से शो कर दिया है. And these ropes, they are of equal lengths, 1 meter, 1 meter. And the whole setup is moving about this common center. This is also moving in a circle. This is also moving in a larger circle, like this. And question says that this 3 kg is moving with a speed of 10 meters per second. About the common center, both these 2 kg and 3 kg, they are moving something like this. Look at this. This is the first rope. At the end of first rope, we have got 2 kg. Then we have a second rope. At the end of second rope, we have got a 3 kg mass. And the whole setup is rotating like this. Now, the question is find out tension force in the first rope. Let's call it T1. Tension force in the second row, T2. The aim is to find T1 and T2. इस स्टेज पर वीडियो पॉज करना, आपने पिछले एग्जाम्पल में क्या क्या समझा, अभी तक आपको सर्कुलर मोशन का क्या आइडिया है, लॉज ऑफ मोशन में किस तरह से फोर्सेस आप डेवलप करते थे, फ्री बॉडी डायग्राम्स क्या ड्रॉ करते थे, उन सारी चीजों की हेल्प लेना एंड ट्राई टू फाइंड T1 एंड T2. नहीं हो सके, कम बैक, टेक द हिंट. जहां से आपको लगता है कि उस स्टेज के बाद, इस पर्टिकुलर स्टेज के बाद, जहां तक सर ने समझा दिया है, इसके बाद अब हम इस क्वेश्चन को खुद कर सकते हैं. देन अगेन पॉज इट एंड ट्राई टू सॉल्व इट. नाउ वी नीड व्हाट? टेंशन T1 एंड टेंशन T2. सबसे पहला काम, इस सेकेंड रोप में जो टेंशन है वो कहां लगेगी? अवे फ्रॉम द बॉडी. दैट्स योर T2. टेंशन कहां लगता है? अवे फ्रॉम द बॉडी. ये T2 किस तरफ लग रहा है? टुवर्ड द सेंटर. एंड देयरफॉर दिस T2 is going to provide necessary centripetal force. What is that? Mass into velocity square divided by r. I said these two are point masses. If they are point masses, then this whole distance is the radius for this 3 kg. What was the radius? 1 plus 1, 2 meters. This is coming 100 by 250, 150 newtons is the tension force in second row. Hopefully ज्यादातर लोगों का ये T2 आ गया होगा. Now let's go for T1. T1 कहां लगेगा? Again, tension कहां लगती है? Away from the body. That's what? Away from the body, T1. ये T1, how do you find T1? हमने बोला T1 is what? Mass. What is the mass? 2 into velocity. What's the velocity? 10 square divided by r. What is r? From this point to this point, radius is only what? 1. And therefore T1 is coming 200 newtons. T1 कहां लग रहा है? Towards center. What is this? Mass into velocity square upon r. Hopefully ज्यादातर लोगों ने ये निकाल लिया होगा, लेकिन आपको जानकर खुशी होगी that this 200 newton is wrong. Now pause the video, think about it. What went wrong with this calculation? देखना क्या गलत हुआ. मैंने आपको हिंट दी थी, you need to draw free body diagrams the way we did in laws of motion. Free body diagrams क्या बोलते थे? What is this? It's a rope. Rope में क्या लगती है? Tension. कहां? Away from the body. What's the body? 3 kg. लेकिन बॉडी 2 kg भी है. This rope connects 2 kg with this 3 kg. This is the action force. Then there must be a reaction force. Where is the reaction force? This is that reaction force. What is this? T2. On this 2 kg, on this 2 kg there are two forces. One which is coming from this rope T1, other one coming from this rope which is T2. 2 kg and 3 kg इन दोनों को कनेक्ट करने वाली रोप में एक्शन रिएक्शन दोनों लगे हुए हैं. अब now look at this 2 kg. If I ask you which one is the larger force, T1 or T2, before that, this is action. इसका रिएक्शन कहां लग रहा होगा? At the center. किधर? इस तरफ. What is the force? T1. Although we don't need it, लेकिन आपको पता है, the person who is holding this rope, he is being pulled by the setup, by the whole setup in this direction of the force of T1. Imagine आप यहाँ खड़े हुए हैं, आपके साथ ये दो रोप सिस्टम कनेक्ट कर किसी ने रोटेट कर दिया. Then you will feel a force in this direction. What is that force? T1. अब जब इस 2 kg की बात करेंगे, मैंने आपसे बोला कि T1 ज्यादा है या T2. एक क्वेश्चन आपके लिए यही बन सकता है कि which part is correct? T1 equals to T2, T1 greater than T2, T1 less than T2. I hope you can see that T1 equals to T2. This is wrong. That's wrong. अगर T1 और T2 दोनों equal हो जाएंगे, then there is no net force. If there is no net force, then it cannot move in a circle. If it cannot move in a circle, then you can see that this T1 equals to T2 is not the correct option. Look at this T1 less than T2. If T1 is less than T2, this 2 kg is under two forces, T2 and T1. Third option says T2 is the larger force. इसका मतलब इस 2 kg पर जो net force आएगा वो कहाँ आएगा? In the direction of T2. लेकिन ये 2 कर क्या रहा है? Circular motion. Circular motion करने के लिए क्या चाहिए इसको? Centripetal force. वो कहाँ लगना चाहिए? Towards the center. क्या करें कि net force 2 kg पर towards the center लगे? There's only one thing which you can do. You must have T1 greater than T2, and therefore this thing is also wrong. Now, ये जो 2 kg है, इस पर net force क्या बनकर आया? T1 minus T2. T1 minus T2. और नेट फोर्स क्या प्रोवाइड करेगा? mv square upon r. What is m? 2. What is v? 10 square divided by r. This is coming 200. T1 minus T2. T2 हमने कैलकुलेट किया हुआ है, which is 150. This is 200. It gives us T1 as 350. कुछ लोग T1 350 कैलकुलेट करते हैं, but problem is ये भी गलत है. When we wrote this equation, there was a problem on this left hand side. हमने उसको मॉडिफाई कर लिया, लेकिन अभी ये पार्ट पूरी तरह से सही नहीं हो पाया है. फ्री बॉडी डायग्राम ने अपने को नेट फोर्स का आइडिया दे दिया, लेकिन अभी भी there is something which is wrong with this equation. If you wish, you can pause the video and think about it, that what is missing still from this part, from this equation. Now, हमने यहां पर क्या किया? mv. What is v? Velocity. किसकी? जिस पर सेंट्रीपिटल फोर्स कैलकुलेट कर रहे हैं. किसका? 2. लेकिन आपने वेलोसिटी किसकी यूज की हुई है? 3 kg की. आपको इस 2 kg की वेलोसिटी को फाइंड करना पड़ेगा v2. This 10 is velocity of 3 kg. इसलिए यहां पर कोई प्रॉब्लम नहीं थी क्योंकि मास कौन था 3, उसी की वेलोसिटी हमने यूज की. दिस इज 2 kg. यू आर स्टिल यूजिंग वेलोसिटी ऑफ 3 kg. किस तरह से आप इसकी वेलोसिटी को फाइंड करेंगे, अब इस चीज को यहां देखना. सपोज वी हैव अ रॉड and this rod is moving in a circle like this about this center C. If you have 2 points on this rod, this and this, let's call them point 1 and point 2. This is point 1 and this is point 2. Then after some time, this rod will reach this position. This rod will rotate and will occupy this position. This one occupies this new position, let's call it 1 dash. 2 occupies this new position, let's call it 2 dash. अगर मैं आपसे पूछता किसका डिस्प्लेसमेंट ज्यादा है, किसका, तो आप बोलते 2 का डिस्प्लेसमेंट ज्यादा है, 1 का डिस्प्लेसमेंट कम है. लेकिन अगर मैं आपसे पूछता किसका एंगुलर डिस्प्लेसमेंट ज्यादा है, थिंक अबाउट इट, किसका एंगुलर डिस्प्लेसमेंट ज्यादा है, 1 का या 2 का, तो आप क्या बोलते कि इन दोनों का एंगुलर डिस्प्लेसमेंट कितना है, d theta. Suppose you move from this position to this position in what time, dt. Then what is the angular displacement, d theta. That's the advantage of angle part. जब आप डिस्प्लेसमेंट की बात करते हो तो ये ज्यादा है, ये कम है. लेकिन जब आप एंगुलर डिस्प्लेसमेंट की बात करते हो तो दोनों जगह का एंगुलर डिस्प्लेसमेंट क्या बना हुआ है, सेम. Which means what? Somebody looking for angular velocity of first point will write this d theta upon dt. What is omega? Rate of change of angular displacement with respect to time. 1 कितना एंगल कवर कर रहा है, d theta, कितने टाइम में, dt. Similarly, if I ask you omega 2, then again you will be doing the same thing, d theta upon dt. इस 2 का भी एंगुलर डिस्प्लेसमेंट क्या है, d theta, और कितनी देर में बना है, dt. What does it mean? It means when things rotate, angular velocities of different points, they are what, same. If you rotate this marker, then each and every point is moving with what, same angular velocity. Which is not true, which is not correct for tangential velocity. इस 2 का displacement ज्यादा है as compared to displacement of 1, and therefore इस 2 की tangential velocity क्या होगी, ज्यादा होगी. And you know the formula for that, v equals to r omega. For point 1 and for point 2, omega is what, same. जिसका r ज्यादा होगा, किसका r ज्यादा है, 2 का, किसके कंपैरिजन में, 1. एंड देयरफॉर जो सेकंड पॉइंट है हमारा, सेकंड पॉइंट v2, उसकी वेलोसिटी ज्यादा होगी किससे, फर्स्ट से. लेकिन यहां हमने क्या कर लिया था, अभी तक हमने दोनों पॉइंट्स की वेलोसिटी को क्या कंसीडर किया हुआ था, सेम. एंड देयरफॉर दिस कैलकुलेशन वेंट रॉन्ग. नाउ इस फिगर के साथ इस स्टेटमेंट को नोट कर लेना जो मैं बोल रहा हूं. राइट डाउन द स्टेटमेंट. व्हेन a system rotates, angular velocities of different points, angular velocities of different points are same. but tangential velocities are not. As we move away from the center, tangential velocity increases. As we move away from the center, tangential velocity increases. Now, एक बार हमने इस चीज को डेवलप किया तो हमने बोला एक काम करते हैं, ये जो 3 kg है, let's find out its omega. How do you find omega? What is omega? V upon R. What is omega? V upon R. What is the velocity of 3 kg? 3 kg. इसकी velocity कितनी है? 10. इसकी radius कितनी है? 1 plus 1 2, and therefore this angular velocity is coming 5 radians per second. किसकी एंगुलर वेलोसिटी है ये? 3 kg की. लेकिन आपको पता है कि यही एंगुलर वेलोसिटी किसकी होगी? 2 kg की. And therefore V2 will be what? R omega. What is R? What is R for 2 kg? 1 meter. And what is the omega? Omega is what? 5. This is coming 5, and therefore you must replace V2 in this equation. In final format, net force is T1 minus T2. T1 minus T2, that is correct. Mass 2, mass is what? 2, velocity is what? 5 square. 5 square divided by R. What is R? 1. This is coming what? 50. T1 minus T2. What is T2? 150 is equal to what? 50. This gives us T1 as 200 Newton, which is correct. Now, what is correct and what is not correct? This part is not correct. You are still getting 200. You are still getting 200, and therefore we will think that what is wrong with this? You're getting 200 also from this calculation part, but somebody using this equation does not take into account these two things, T1 minus T2. At the same time, he doesn't care about velocity of this 2 kg. This is just by chance. By chance, you're getting 200 and 200. If you change the data, you can see yourself. If you change the data, you will find that these two things are not coming same. This is the correct version. क्या चीजें correct की हमने? Total force. What is the other thing जो हमने चीज सही की वो थी क्या? Velocity part. It's an important question. Good question. Note down this.